Hello friends, in today's video we'll be discussing all about Seaborn library and its excellent data visualization tools that it provides. So we'll be going through the pair plots, distribution plots, joint plots, hexagonal plots, box plots, violin plots, scatter plots, regression plots, KDE, bar plots, box plots and much more. So launch your Jupyter notebook. This is something like home page will look like this. We've created a folder as data analysis. We open the same and I have my data tips. I've created a new Python 3. In that my new notebook is tips dataset. So it's already I have created this tips dataset. Now we start with loading our data. Now remember this tips data is already in the Seaborn library. So what we do is we will import this data from Seaborn. So what we do first, we import Seaborn as SNS. This is loading. Hit shift and enter for more codes. The lines, these lines. Then what we do is in the object called df we will store sns dot load dataset of what tips, right? Hit shift and enter and it's loading. See the sign here, it's telling us to wait. So it's been loaded. Since it's been done, you can see it here also and here also. So now we will see what have we got. df.head will give us first 5 rows and columns. Okay, first 5 rows. So we can see here the data which we have. So we've got total bill, tip, sex, smoker, day, time and size. Let's check the shape of our data. So we write df.shape, right? And the shape is 244 rows and 7 columns or attributes. So now we want to make some utilization of this data, how to represent this data. So what we do is we use visualization tools as to understand how many smokers are there and what is the proportion of smokers and non-smokers. The smokers giving how much tip, what is their contribution towards total bill, and their frequency on which day is maximum, which time of the day is maximum. So we can infer information from this data and plot it. So let's just also check the df.d types of our data. What is it? So now you see total bill and tips are in float. Rest is category. That means it is a categorical data. Male, female, no, yes. And the size is in integer form. Alright, so we don't see any standard data. That means every unit is the attributes are not in the same unit. Few are categorical, few are in numeric. So let's go to the visualization part now. So the visualization of the data, go to markdown and shift enter. So the visualization of data, it's a good practice to have many codes like this, code lines. So we start with the distribution plot. Let's start with the distribution plot. Okay. Distribution plot. So what do we write here? We write here sns dot dist plot, and in here we call our object df. In that let's plot tip. Okay, and this will give me the distribution plot of my tip. So I can see that maximum tip I have received between 2 to 3.4 USD, right? So 2 to 4 USD is the maximum concentration of my tip. Similarly, you can find of total bill. So I can just write the distribution sns dot dist plot df, and I write here total bill. So you can also receive of total bill total bill, and you can just provide here the color for just good representation. So I can just write color equals to G for green. So let's see. Okay, so we've gotten here. So the total bill, the maximum concentration is between 10 to, you can see here, like 20 USD. So maximum bill is paid between this limit, and the corresponding tip is $2 to $4. Okay, so now we plot, and then let's come to the next type of plot, and that would be, let's go for pair plot. Okay, pair plots. Here we write SNS dot, it just gives me complete picture of my data. SNS dot pair plot df. Okay, so this is giving me the entire this thing, tip, total bill, and size. Remember one thing, that this is only giving me the numeric distribution and not the categorical. So it is just giving me total bill, tip, and size, which are in number format and not categorical. So we can just infer that tip and total bill, they are positively moving. Higher the bill, higher the tip. So we can just infer this from here. And the size, you can see maximum is 2 here, and total bill maximum again lies between 20, 30, 40. See, this is the distribution. Okay, now let's see now another feature of pair plot. What I can do is I can write SNS dot pair plot. Here I write df, and in this I give hue equals to, let's say, sex. Let's find out. And I write palette equals to HUSL. So what does it give me? It shows me the pair plot along with male and female. So I can see here the total bill given by males in pink and female in teal color, right? And here we were finding just the two being segregated together, difficult to distinguish between male and female here. So I have just made it like this. Similarly, what I can do is, instead of this hue as sex, I can make it as smoker, and then you see this. So when I do this, I can get how many smokers are paying how much bill. So smokers, this is here, and non-smoker is in teal color. So no, the not smoking are paying bill which are being concentrated in 20 to 30 this thing USD, and also are paying tips between 2 to 4 or $5. Okay, so we can similarly infer different information from this. Now let's go to bar plots. Bar plots. SNS dot bar plot. What you write here, we give x and y axis here. Okay, so x I want as total bill, and y can be sex. Okay, and data I'll get from df, and palette is, let's say, cool worm. See, this is the bar plots. Can you see this thing? This distinguishes bar plot from normal plots. So this thing, so I can see that the total bill paid by females is ranging between, the highest is somewhere around 17 or 18, and males it's 20. So we can see here that males pay more bill as compared to females. Similarly, we can plot bar plot. One more I'll show you. We can similarly play around with different features here. And again I give x equals to, let's see, day. Okay, which day, how many tips have been received on which day. So I can just take one categorical and one numeric data. That's what I'm taking, one numeric and one attribute of this thing. I can also interchange these into x and y axis depending on my need. So you can play around, make it more representative as per your demand, and data is equals to df, and I will choose the palette is as, let's take it as magma. Okay, magma. Let's see what happens. So this is magma. So you can see here, when I write hue, this is the hue here, and it gives me a legend also. So the smoker and non-smoker. So I can see the in different days how many smokers are there and non-smoker, and what is the tip they are paying. So this is what I can infer. I can represent. I can tell my team that, see, on Sundays the smokers are giving much tip because they are coming with their families or something, and they are paying. They are eating out. On Sundays also non-smokers are also paying the maximum tip. So that means on weekends people usually go out and dine. Okay, so you can make out certain crucial information from this, that smokers, the ratio, the proportion of which day you are getting the maximum revenue in bills and tips. You can change this tip as total bill, also change this hue as, sex, day as, time, anything, and see how does your data look like. So now let's go to, after doing this bar plot, we will go to another plot, and that is the count plot. So the count plots are for the categorical data, I'll say. So let's first, I'll tell you how to find out the count first. So df, I'll take this. I want to take out the count of number of females and males. What is the count? So I'll write value counts, right? And let's see. So I get males as 157 and females are 87. All right. Okay. Now let's plot this data. So how would I plot it? I'll plot it as sns.countplot, and in this I will give sex. I will give data equals to df, and I can just give palette if you want. Palette tte. Okay. Palette could be muted. So this is what it gives me as a count plot, males and females. So you can see the number, it's 87, and here it's 157. Similarly, you can plot of other categorical data like, smoker, non-smoker, like that. Now the next count plot I will show you is of smoker. Okay, so let me show you of day. So let's first count the day, and dot value counts. So you can see Saturday, you've just got 4 days here, and you can see this Saturdays and Sundays, especially Saturdays, it's 87. So now let's just count sns dot, let's plot it, sns dot count plot, and in this count plot I will write day because it will plot day. It will take data from df, and what else we can give? We can give palette here, and this palette could be HLS. Okay, right. So we've got this. So you can see with different colors that Friday is the very low count we have, and Thursday the count we have. Saturdays is the most count we are having. So number of people visiting on Saturdays is like this. Okay. You can also write include a hue. If you want, let's take hue as smoker. Okay. So this is what we get. That, and if you want to distinguish between how many smokers and non-smokers are there, so I can just see that in this day, in Saturdays, what will I get is so on Sundays I'm getting most of the non-smokers dining out, and on Sundays it's nearly equivalent on Saturdays, and on Thursdays again non-smokers are more. Okay, so okay, after this let's come to another plot, that is our I'll show you another plot. This is okay, and that will be violin plot. Okay, violin plots. These violin plots, they help to see the data both in terms of the kernel density and also on the form of box plot. So what we do is SNS dot give the name violin plot, okay, and I will define X as, let's take it as sex, and how many people are coming, males or females, and what are the total number of bills, what is the total number of bill they are paying on y-axis. I will take the data from my df object which I have created, and the palette will be, okay, I'll take one rocket and this is what I get to see. This is the male, number of male and female. So this is the kind of a violin plot which we see the most of the concentration is here. This is the kernel density estimation and also the box plot it is giving. So you can see the females, they're paying less total bill as compared to males, right? And the extreme bills like 60 or above 50 is being paid by males as compared to females, okay? All right. So what could be the reasons males are earning more, or they are fond of eating outside, whatever. Well, now the next is we come to our, I'll show you box plot. So one more thing in violin plot, I can just tell you SNS dot violin plot. In this also we can include hue. Okay, so let's take X is equals to as total bill. You can take tip also if you want, and in Y I'll take okay, day. All right, let's see the day, which day what happens. Data equals to df, and let me take hue, and let me take hue as time. All right, let's use time here, and let me take the palette as ascent. Okay, so this is lunch and dinner. So we can see here on which day lunch dinner proportion is more. So you can see here that on Saturdays and Sundays mostly people are coming for dinner and they are paying good bills. So outing is much on weekends as compared to weekdays. Alright, now let's come to another type of a plot, and that would be box plot. Box plots again for numeric data. I can just write SNS dot box plot. I will write here smoker, and total bill. So again in quotes I will write total bill. From data is equals to df palette equals to, let's again take HUSF. Okay, so I can see here the smokers and non-smokers and the total bill they are paying. So here the smokers and non-smokers. So in non-smokers you've got many outliers. That means the spread of the data is much here in non-smokers who are paying much greater bill as compared to the smokers. Okay, so this was box plot. Similarly you can plot on different various things. Now let's come to joint plot. In joint plot, as the name suggests, what happens in joint plot is joint plots. Okay, so here we'll just write SNS whatever joint, like joint plot you have, and here X equals, we'll write here, let's take tips. Okay, I think it's tip, and Y, let me take total bill, and data again I'll take df. See, the arguments are the same, and the kind I want is what kind I want. I can just mention here the kind I'll take. Okay, I will take hexagonal, HEX. Okay, I can also mention the color here, but it's okay. So this is what you see here. See the total bill and the tip. The maximum number of total bill is concentrated. Again, we can see here in 10 again to 30, that is what it's giving me. And the tips are concentrated here between 2 and 4. That's what the major part we are seeing, and also we can see it here in the histogram part. So this is the joint plot. Similarly, you can also see one more thing here as SNS. Again, like I'm using the joint plot here, and the joint plot, I'll take x equals to, again take total bill, and y you take tip, okay, and data can be df. Our data is in df, and kind. Now, I'm using kind as a different thing, and this kind is regression. So this is what I will get. The regression line, the best fits drawn. Again, I can see the concentration and the different representation. Now there are different representations here. Again, we can see it is concentrated here 10 to 30 maximum, and tip is again 2 to 4 USD. Okay, so this was all about joint plot. Okay, now we will come to scatter plots. This is most interesting. Scatter plots. So in scatter plots, let's just plot SNS dot get plot. Here we'll write x equals to day, y let it be tip, in which day which day maximum tip is received, and data is df. So we can see the categorical plot like this. So on Saturdays, again, you're receiving the maximum tip and also most of the tips. Okay, so please don't miss out on Saturdays, those who are working in hotel industry. Okay, now so SNS dot cat plot as per this data. Yeah. Now I'll take x equals to, let's find out who is paying how much amount of tip. Okay, tip, and I will take one as, I'll show you one more thing, that is I'll show you one thing as data is equals to df, and I'll take the jitter as false, and now you see the magic happen. See, jitter, what does this jitter means? Look at the data. This just gives me a simple line, and it is not segregated like this. It is not distributed like this. So jitter just gives me one simple line if you don't want to see this thing. So I can see male and female. Maximum male tips received from males is around $10, and from female it is around 7 or so, 7.5. Okay, now let's come to a different kind. I'll tell you. Now this is SNS dot get plot. There's another variety here, so we can take here as x as let's take here smoker, and let me take y as tip. Okay, and I can write here kind equals to swarm, and from the data it will plot from df, and I can just take hue. Okay, hue as, so more complexity I'm adding here as x. Okay, so this just gives me the males and female, that the number of males and females who are smokers and non-smokers and paying the tip is in $2 and $6. We can just see that here that non-smoker males are paying more tips in $2 as compared to non-smokers, right? These smokers. So we can just infer from here and see males non-smoker are paying much tip, and male smoker both are paying the maximum tip here. Okay, so smoking doesn't prohibit you from giving much tip. So this was about scatter plots. Now let's come to our heat map. Okay, SNS dot heat map. We'll find the correlation. So the correlation, what can we write here? Simple, SNS dot heat map, and df.corr. This is what we do, and I can write just a note equals true because I want to see the values in there. So we will see this plot correlation between the numeric data, and we see here that tip and total bill are positively related, not high, but yes, positively related, 0.68. Yes, so we've seen pair plots. Okay, you can also see df.corr. If you don't want to plot it, you can just see the size, the shape of it. How does it in numeric data instead of plotting it? But plotting gives you a good representation of your data. So we've seen here various plots of Seaborn library which it offers. So here we have seen distribution plots. This is also histogram and KDE. This is the kernel distribution, kernel density estimation function. So you can just see the function. This is an abstract form of histogram. Now, after this, we've seen pair plots between two or more attributes. Bar plots we have seen. You can also plot bar plot like this, setting hue and different days, different parameters, comparing it. Count plots, categorical plots for sex, smokers, everything, counts and everything it will give you. You can also add hue in that. Violin plot we have seen. Then box plot. This is here joint plot. You know what you can do here? You can also write here KDE. See, if I give here KDE, this is KDE, kernel distribution. So you can again infer that this is the maximum part of it, and data is how it has been segregated between $10 to $30, right? So you can just change your kind and see different things happening. This is the categorical plot. You can fix different sworn and different features in it to get different representation, data visualization. And this is the most standard we see, very quick, easy, and that is called heat map, or this is a correlation map which we see in SNS. So this was all about the Seaborn library, and I hope I've covered all the graphs which Seaborn offers, and you can use it in different plotting, different images, and different data analysis, which we'll also see further. So thank you for watching.